Now the next curve. Trace the curve a square x square equals y cube bracket 2a minus y. The first point is a symmetry. Here, if you look at this curve, equation of curve, all the terms in x are even power. Again, all the terms in y are not even power. All the terms in x are even power. Therefore, this curve is symmetric about y-axis. Whether it passes to the origin or not, that we are going to check. Curve passes to the origin. This curve can be written in this way: y raised to power 3 into 2y, y raised to power 3 into 2a, y into y cube is y raised to 4. Okay, this does not contain free constant term. This is variable term, this is variable term, this is variable term. It does not contain free constant term. Therefore, curve passes through the origin. It passes through the origin. The coordinates of the origin are 0, 0. A square x square 2ay cube and y raised to 4. Degree of this term is 2, degree of this term is 3, and degree of this term is 4. Only we have to consider the degree of variables only. Now lowest degree term is a square x square. Lowest degree term we have to equate it to 0. And here in this curve, a is greater than 0, that is given to you. Here a is positive, therefore x square equal to 0 by a square means 0. And here we have this x, take square root of both the sides, x equal to 0 and x equal to 0. Okay, here we have tangents at origin. Okay, but these two tangents are same at origin or at any point. If there are two same tangents, then that point is a crust point, In the previous lecture, I explained this. This 0, 0 is a crust point. 0, 0 is a crust point because at this origin there are two same tangents, x equal to 0 and x equal to 0. Now you try to check the asymptote, whether the curve has asymptote or not. So this curve y cube into 2a minus y raised to power 4. So this curve has no asymptote. Why it has no asymptote? Because highest power term in y is this one, and the coefficient of highest power term is constant, and that cannot be equated to 0. Okay, you cannot equate this minus 1 to 0. Therefore, the asymptote parallel to y-axis is not there. If you equate coefficient of highest power term in x to 0, okay, this is also not allowed because here a is greater than 0, which is given. Means curve has no asymptote. Okay, parallel to x-axis, in bracket I am writing parallel to coordinate axis. Coordinate axis means x-axis and y-axis. So the region of absence we are going to find. Look at this curve very carefully. A square x square y cube to a minus y to the power 4. Now can you express x square in terms of y? In terms of y I have expressed x square in this way. Otherwise you can guess in this way that the curve is symmetric about y-axis. Curve is symmetric about y-axis. It will be better to express x square in terms of y. Now, for which values of y x square is negative, that we are going to find. If y is less than 0, means y is negative. Y negative means y is minus a, y is minus 2a, y is minus 3a, y is minus 4a, and so on. For negative value of y, if y is less than 0, then x square will be negative. Okay, you can put any value of it. If you substitute y is equal to, if I substitute here y is equal to minus a, what will happen? Minus of 2a raised to power 4 plus minus a raised to power 4 by a square, and this is minus 3 a square because a raised to 4 by a square. Means for negative value of y, x square is negative. Therefore, curve does not exist for negative value. For negative value means for y less than 0. Below x-axis, equation of x-axis is y equal to 0, equation of y-axis is x equal to 0. This is the region of absence now. This is y is less than 0. Here, curve does not lie. For any other values of y, x square is negative. If you look at this very carefully, then if you put y is equal to 3a, 5a, y is equal to 6a, y is equal to 7a, then x square will be negative for that. Okay, for y is greater than 2a, here I am writing for y greater than 2a. Greater than 2a means y is equal to 2a, you can substitute y is equal to 2.5a, y is equal to 2.25a, y is equal to 4a, y is equal to 5a. Because for all these values of y, x square is negative. Therefore, curve does not exist for y greater than 2a. And y greater than 2a, how do you draw this region y greater than 2a? This is y is equal to 2a, and this much value of y from origin is 2a. This is y is equal to 2a. And y is greater than 2a means more than 2a. Y is greater than 2a here. This is the dotted portion which indicate y greater than 2a. Or at this region, value of y is greater than 2a. Here y is greater than 2a. Means our curve will lie in between these two lines, y equal to a and y equals 0. In this strip, the curve will lie. Now, the much more work is reduced. So what I'll do, I'll find some points, 3 to 4 points, and I'll trace the curve directly. Now, this is 2a, this 50% is a, this is 0.5a, or a by 2 you can write. This is what 1.5a in this way. This is 2a and 50% is a. Here 1.5a. Here, what is value of x? Here x is expressed in terms of y explicitly. Therefore, what I am going to do, this is equal to 2a y cube minus y raised to power 4. This divided by a. I am writing outside of this divided by. And the various values of, different values of y I will be putting, and the points I will be getting in terms of order pair. Now, for put various different values of y, for y is equal to 2a, what will happen? 1 by a under root of 2a y cube minus y raised to power 4. And if you put y is equal to 2a, what will happen? X equals 1 by a, here 2a power 3 minus 2a power 4 in this way. This is 8a cube, 16a raised to power 4, and this is 16a raised to power 4 is 0. Means for y is equal to 2a, the value of x is 0. Means first point we have obtained 0 to a. This point we have obtained, and the coordinates of this point 0 to a, because this point is on y-axis. If you put y is equal to a, what will happen? See, 1 by a under root 2a. I am putting y is equal to a. I am putting y is equal to a. What will happen here? 1 by a, this 2a raised to 4 minus a raised to 4 is for, this is for y is equal to a. If you put y is equal to a here, then value of x also a. The second point is a comma a. Second point is y is equal to a, and this one, this point here. This is the first point, this is second point. Y is equal to x equal to a and y equal to a. The coordinates of this point a comma a. For y equal to 0.5a, 0.5a means a by 2. If you put y is equal to 0.5a, y equal to a by 2, for y equal to a by 2, the value of x is 0.4a. Next point we have obtained, x is a by 2 or 0.5a and 0.4a. This is 0.5, this is 0.5, below little bit below that. It is 0.4 and a by 2. This 0.4 a by 2 means here is a by 2 and 0.1 here. Okay, by freehand I am drawing this one. So this is the next point, which is a by 2 comma 0.4a. First point, second point and third point. If you put y equal to 0, what will happen? See, for y equal to 0, the value of x will be 0. Means for y equal to 0, value of x is 0. Means 0, 0 is also included, and it is very clear that this curve passes through the origin we have written. It passes through the origin. Means for x equal to 0, y equal to 0, so this point is also an. Okay, first point, second point, third point, now the fourth one. So you can take other points also. Value of x is 1.3a for 3a by 2. 3a by 2 means 1.5a. This is the next point we have obtained. The next point I am going to plot. Here x is 1.3. This is a 1.3. This is 1.5. Here in between. And 1.5a is this one. This point we have obtained, and this point is 1.3a, comma 1.5. All those points you have to join smoothly by maintaining the curvature. This is very important. Okay, you have to maintain the curvature. This curvature, this nature you have to maintain here so as to get the curve. This curvature you have to maintain. The smoothness should be there. There should not be the discontinuity. And this point is a cusp point. Cusp point means at this point, at 0, 0. See, at 0, 0, there are two tangents. Now this half portion we have drawn, and the rest of the half portion by symmetry you can draw. Because this curve is symmetric about y-axis, so this portion you can draw by symmetry. This much we have traced, and this we have drawn by symmetry. Because it is symmetric about the line x equal to 0. Okay, we have written here, it is symmetric about y-axis. It is symmetric about y-axis, therefore this portion we have traced, and this portion is directly drawn. In this way, we trace the curve. We stop here. Thank you very much.